What is up, everybody? All right, this is 6.6 part 1. We're going to only talk about trapezoids today. Okay, so we're moving away from that parallelogram family, getting into a different subcategory of quadrilateral. So as I just said, so a trapezoid, all right, special characteristic is that it has one pair of parallel sides. Okay, so the two sides that are parallel are always opposite each other. Okay. So we call those sides the bases. Now I know we reuse a lot of terms. We've used bases in base angles and isosceles triangles. We use base in just normal triangles. But for a trapezoid, the two sides that are parallel, we call those the bases. Okay, so base 1 and base 2. The non-parallel sides are called the legs. So again, that term coming up again. Now the important thing to know here is that the base angles are formed by the legs and the bases. Okay, so these are base angles here and here, and these would be base angles here and here. Now, before we move on to isosceles trapezoid, I just want to point out one theorem that we need to remember. So remember when we had parallel lines and we had our transversal, right? And previously in the section before this, when we were looking at diagonals of parallelograms, rectangles, rhombuses, and squares, we had that alternate interior angle, right? Which was congruent. With the trapezoid, we're going to have consecutive interior angles. So angle 1 and angle 2. Okay, and if we were to compare that, that would be like angle 1 would be right here, angle 2 would be right here. And remember, consecutive interior angles are supplementary. So angle A and angle D would add to 180, and angle B and angle C would also add to 180. Okay, so consecutive angles. And then obviously A and B, that's not a pair that we know with parallel lines and transversals. Okay. So next we move on to, now the majority of the work we're going to be doing, I think, is going to be isosceles trapezoids. There'll be a couple non-isosceles, but an isosceles trapezoid is a trapezoid where both the legs are congruent. So look just like this. Okay. Now, we have all of these things that are still true for our normal trapezoid. So one pair of parallel sides, those are called the bases. The non-parallel sides are called the legs. The base angles are formed by a leg and a base. We still have this pair of angles are supplementary, along with this pair of angles being supplementary. But what we have now is the base angles are congruent. Okay, so notice that these are not base angle pairs. That's your supplementary angle pair because it's consecutive interior. The base angle pairs are just like an isosceles triangle base angles, that they share a side. Okay, so these two are your base angle pairs, and this is a base angle pair down here. The other thing that's true about an isosceles trapezoid is the diagonals are congruent. So if we were to draw these in, AC is the same length as BD, or congruent to BD. Now, as far as trapezoids go, that's all the new information right there. Okay, so common things to remember is that the angles that share a leg, so A and D and B and C, are supplementary. Isosceles trapezoids, angles that share a base, are congruent, the base angles. And the diagonals are also congruent. So let's get into some examples. So looking at these are just really quick problems that we can do. Hopefully you printed this out, the outline, so that you don't have to copy these down a bunch. So when I look at this, right, I know that these two sides are parallel, which means that angle T and angle U are supplementary, so angle T has to be 110, 180 minus 70. Looking at number 2, it's the same concept, right? We have our parallel lines. That would be a consecutive interior angle pair, so 9x plus 12 plus 7x minus 24 equals 180. Okay, you would solve that out, and then it's asking us to find angle B. We would plug x back in. Now looking at number 3, I know this is an isosceles trapezoid because of the congruent legs right here. But even though it's isosceles trapezoid, R and Q are still supplementary, so this would be 80. What now we can know is that this angle would be 100, angle S, and angle T would also be 80 as well. The other thing to remember, guys, is because it's a quadrilateral, all 4 angles have to add up to 360. So 100 plus 100 is 200, 80 plus 80 is 160, 200 plus 160 is 360. And then looking at 4, okay, isosceles trapezoid, which means that this would be a base angle pair of 40 degrees. All right. And just some more problems based off that, right? So again, isosceles trapezoid, 4x minus 4 equals negative 15 plus 5x. For number 6, now for this one, it's an isosceles trapezoid. So remember, this angle is the same as this angle here. And I know angle W is supplementary with angle X. So my equation here would be 7x plus 14 plus 13x plus 6 equals 180. So pretty much, guys, they're either going to be equal or they're going to be supplementary. Pretty straightforward. And then let's look down towards the bottom. We're just talking about segment lengths. So GE is 21. Okay, they're asking for the length of FD. Well, we know that this is an isosceles trapezoid based off these markings. And remember, diagonals are congruent, so FD would also be 21. Looking here, again, isosceles trapezoids would be x plus 9 equals 2x minus 1. All right. So that's the basics of isosceles trapezoids and normal trapezoids. But there's one last thing we need to talk about, and that is the mid-segment of a trapezoid. So notice in this diagram, I have 2 points on each leg. And those points are the midpoint of each side or each leg. Now, if I connect those, that is the mid-segment. It's connecting the midpoints of the legs. And so that length has a relationship to the bases. Notice that it's also parallel to the bases as well. Okay? So what's important about this is that the mid-segment length is half the sum of base 1 and base 2, or pretty much it's the average length of the two bases. Okay? The other thing to point out that's really important is we now have corresponding angles. So angle A and angle D are still supplementary because they're consecutive interior, but what's also true now is this angle is congruent to angle D, and this angle down here is congruent to angle A. Okay, and that is because they are corresponding angle pairs. Okay. And you have the same thing on the other side, where angle B would be congruent to this angle, and then this angle would be congruent to this one down here. All right. Just something to point out. All right, so let's just do a couple problems that are mid-segment examples. So we're trying to find the mid-segment of this. Now I know MN is equal to 1/2 times base 1 plus base 2. So the length of MN equals 1/2 base 1 plus base 2. So then MN equals 1/2 of 32. Half of 32 is 16. Okay. Formula would be the same for this one, next one. FG equals 1/2 of 4.5 plus 13.1. I think you guys get the idea, right? Now it gets a little more complex if I add a little bit more variables and whatnot, okay? But the setup is still the same. So x plus 12 equals 1/2 of 3x minus 4 plus 21. Simple. Combine like terms in your parentheses before distributing. Now get x plus 12 equals 1/2 times 3x negative 4 plus 21 is going to be positive 17. Now, if you don't want to divide by 2, because both of those are odd numbers, which means we get fractions, the other thing we can do is multiply by the reciprocal. So that would give me 2x plus 24 equals 3x plus 17. I can subtract the 2x, subtract the 17, so then I get 7 equals x. Okay. Problem on the right, 4x minus 11 equals 1/2 4x minus 24 plus 50. Simplify on the inside. 4x plus 26. Now, because these are even numbers, it's going to be faster for me to distribute the 1/2. So 4x minus 11 equals 2x plus 13. Subtract the 2x, add the 11. 2x equals 24. X equals 12. Done. Right, and now guys, just kind of looking at these top two, we're now given the mid-segment, we're asked to find another base. So that would be 21 equals 1/2 x plus 25. Now I would always pretty much recommend multiplying by the reciprocal here, so that way I don't have to divide x by 2. So I get 42 equals x plus 25. Subtract the 25 from both sides, x equals 17. All right. Next one, 8.2 equals 1/2 x plus 12, just to get the setup correctly. Okay, and again, I would recommend multiplying both sides by 2 over 1. Here, 3x minus 11 equals 1/2 4x minus 18 plus 12. So again, for this problem, because all of those are even numbers, I would probably divide or distribute the 1/2. Okay, so notice this is a lot of algebra once you get to problems like this. 2x plus 18 times 21 plus 2x plus 15. It's just ability to do your PEMDAS, right? Simplifying, parentheses, exponents, multiplication, division, addition, and subtraction. Okay, so for homework tonight, you're only doing the first half that has to deal with the trapezoids on that sheet. Let me know if you have any questions.